this video, we show the practices that support ongoing changes in student thinking. In part 1 of this 2-segment video, students had been introduced to the idea of feedback loops in the Antarctic that involved an increasingly warming climate and ocean. They then looked across different kinds of data to reason about these effects on the populations of organisms. In this second video, we finish this lesson by using what students know now to revise their models. These informed revisions make the models more consistent with evidence and represent the scientific practice of modeling.
We want to practice this, so you should be doing this somewhere in the middle of your unit after you've done a few lessons. You've got new information, new data, ideas have been talked about that you didn't have access to before. And so you need to return to your models. It's authentic science. Scientists make changes based on what they know. Now, we are not approaching right answers. We're just trying to create better links between parts of this ecosystem. You can tell there aren't any right answers at all. Scientists themselves do not exactly know how all these things work together. The object is just to create a model that fits with the data and fits with the information better than your model did a few days ago.
Yeah, so when you have them go back and look at them, sometimes it feels like they might just want to start over, or do you really have them just like, I mean, what's the better method? Do you have them like scratch this out and change it, or do you have them?
No. Yeah, from doing this 100 times, what I would say is, remember, kids will get model fatigue if you ask them to redraw stuff multiple times. So I'm now recommending that you go back in the middle of your unit and have them adjust their models, but we'll try a technique today that we also did during the tanker unit, in which you don't redraw your whole model, you just add commentary to it. And this we'll do with sticky notes, and this is very helpful for your English language learners, because often the kind of dialogue that I hear at the tables here, if you're an ELL student, you just cannot keep up with the pace of the talk. You can't contribute, you can't ask questions. But now is a time we can slow down the pace of class. And I'm going to ask you, so I will model this. We have this guide about how we can record some comments from what we've learned and put it on the models. So here's one decision you have to make as a teacher. These are post-it note comments or sentence frames that will guide post-it note comments. Now, should I have you put comments on somebody else's model, or should I have you put it on your model? Because you can do either one. And I'm going to monitor how you're using these sentence frames, because you're not supposed to put, I like this, I don't like that. We're supposed to be talking about the ideas that are represented in your model. So, Esther, what are you thinking you want to add to this?
Yeah, I'm thinking we should add sea ice.
You didn't have sea ice on there before. You just had like organisms, so why are you now thinking sea ice is important?
Because it's in the data, so we think it's an important player, even though it's a non-biotic thing. So it's something that we didn't think of could affect biotic interactions.
And the trends follow the trend also.
Yeah.
And the krill.
You mean the sea ice data?
The sea ice data, the decreasing sea ice is decreasing similar to krill density and the penguin density. So it seems like it might be important.
Okay, it seems like it's all going down. And you guys have talked about the why behind the data, why it would be the case that if sea ice goes down, Adelies also go down. So, Kimmy, you haven't said anything yet. You want to be brave and say the why behind the data?
Yeah. Krill, they mostly eat phytoplankton, so if the sea ice is decreasing, the phytoplankton is also decreasing because they're only found under the sea ice in winter. And so if the krill is decreasing, then the Adelie penguin is also decreasing.
Do any of your partners want to add to that?
Yeah, so the phytoplankton, I think from this, says that in the winter, the only place phytoplankton can grow is on the underside of sea ice, like you're saying. So it is a requirement for this phytoplankton's niche. And so without it, it's the producer in this ecosystem. So without it, the krill can't grow.
Without that, the Adele can't get there.
So if we don't have a producer in this ecosystem, Amanda, we did a little bean activity where the beans represented energy. So what does that imply if we don't have a producer in our ecosystem anywhere?
We don't have any beans.
No beans to go around?
We have no energy. Or we have not enough energy. So if there's not enough of a producer like the phytoplankton, there won't be enough energy to support higher level consumers, which require 100 times more energy.
Okay.
Like the penguin.
So now as a teacher, I'm thinking, this group has talked about energy getting passed around and starting off with phytoplankton, so I'm going to make sure I listen in other groups or prompt them for that because I forgot about it. And it links to an activity we just did. So I'm mindful that you guys are thinking about energy. So here, let me give you a leading question. So if you want to include this idea about energy as well, is there some way you can represent energy in your diagram?
You do this transition. How do you leave? Because the kids are really engrossed in a conversation and I don't want to leave all the time.
I have to go.
How do you ask them a question and you're like, okay, peace. Like, how do you
Or they'll start talking to me. Okay, hang on, Miss Garden, I want to talk to you.
Right, but I've already had like 4 or 5 turns of talk with you guys as a group.
I understand that, but as a student, I don't really care about other groups. But I'm just saying, no. I know, I'm just saying.
I know, I just have to go.
Okay.
Other kids need it, but I'm leaving you with a question that's doable for you, and that's how can we
That's a
represent
good
If we leave it as a food web, I don't know how we do anything else. But if we make it more into like a model, then we can add in CX and stuff. But is it supposed to be a food web? Or were we just supposed to put these on here over
We don't have ice up there, you want to add ice?
But it wouldn't be a food web then, is that okay?
Other people have ice.
Like when you do things like ice and,
You can put a question on there about,
okay, I don't know.
Going to different groups, seeing if groups have like an idea that another group may not have. So they were talking about energy, that you have to have phytoplankton in the system, otherwise you can't pass energy along. That was unique to their group. What I'm hearing now from your group is this idea of when one food source becomes unavailable, some of these organisms will switch to another one. So can you guys be ready to share that out and maybe flesh that idea out a little bit more when we share it?
Sure.
What is helpful to do when students are working on making changes in the middle of the unit is to find out if particular groups have an idea that other groups may not have yet. And remember who those groups are and how they might share out about that idea. So when I was visiting with this group, they had a particular kind of idea and they had a different idea that I'm not sure was shared by the rest of the class. So I'm going to ask 2 groups to share out about that idea, and I prepped them for it so that they could be ready to do the sharing out.
Yeah, I did sea ice, which is an abiotic factor, and therefore I drew a dashed arrow. Because it is necessary for phytoplankton, which are primary producers, to grow enough biomass, or to create enough biomass, to support higher trophic levels, such as krill, which require, and then the Adelie, which require 10 times more than that, right? Don't correct me if I'm wrong. So we're guessing that phytoplankton might live without the sea ice, but that it won't be a big enough, there won't be enough biomass to support higher trophic levels, and so this abiotic factor of sea ice allows for that, those higher energy organisms to exist.
Are you calling the sea ice the keystone species? Is that what that?
No. Species.
Oh, sorry.
Oh.
It was just there. We just
Okay.
put the sticky note there for some reason. Yeah, sorry.
I just didn't know.
This one, yeah.
So what did I ask you guys to do on your poster? What was my leaving question for your group?
I don't remember because I asked you a
Energy?
question about it.
Something?
Oh, energy.
Well, I gave you a leaving task. You don't remember my leaving?
Because I wanted to know how to leave a group and then I.
You want to know how to leave a group and you were too concerned about that? My leaving question was, they're talking about energy. And I asked Amanda to relate that to the bean activity that we did.
Well, okay,
right.
sorry, so I was trying to, right, so that's what I was trying to do, was just talking about the trophic levels, that if we don't, we might have some beans here for the phytoplankton without the sea ice, but beans being energy. But when there is sea ice, we'll have enough beans to pass on to the next level. Is that a good enough analogy?
Mm-hmm. Okay.
There's also sort of a feedback loop where if the Adelie population goes down, we're hypothesizing that the leopard seals will, because one of their main food sources is the Adelie, that the leopard seals will then start feeding on krill, which is their other primary food source. And so if that happens, it's kind of like this feedback loop where now the Adelie's population might even go lower and lower because their main food source is getting taken by the leopard seals.
One thing that I wanted to point out is that the sea leopards don't switch over to the chinstrap penguins as the prey as much because they're harder to catch, because they are better swimmers in open water. In terms of switching food sources, when the Adelie penguins go, the population decreases. And one of the reasons was from the data, that graph of the chinstrap population increasing.
Okay, so Farik and Tina, can you revoice in just a couple sentences what part of their theory is that they want to add to what we've all been talking about?
Yeah, so part of the theory was that as the Adelie penguins are going into decline, the leopard seals still need to find a source for their food. And so they're going to start eating more krill. And I'm kind of confused as to why they wouldn't start eating chin straps as well. But can't catch them. Okay. That would be why, yeah, I wouldn't want to waste my energy trying to get something fast in open water when I could just eat krill there in front of my face. Does that make sense?
I would add on to something that they said, and then a question I have is, in addition, when the krill population drops, that's going to force the Adelie population to drop as well, because that's the Adelie food source, so they're talking about how to loop. I would like to know more information about these other penguins they mentioned in here that are the leopard seal's main food sources.
Can you say what is wasting energy? Who's wasting energy to get what?
Yeah, okay, so the leopard seals are hungry because there's less Adelie penguins. So now they still have to look for food. So they're going to look towards the krill and other penguins to get that food. They won't go towards the chinstrap penguins because they're better swimmers in open water, the chinstraps. So the leopard seals won't use the energy that they have to try and chase after a penguin they might not catch. They're instead just gonna eat krill that probably can't run away as fast.
So when you're saying it could waste energy,
Yeah.
what is that leopard seal doing?
Moving in the water. It's doing any living. It's just doing things.
Or it's like you have $10 and you could go to the grocery store and buy some food and then cook it up and then prepare it and then make it and then eat it and use a lot of energy to do that. Or you take this $10 and just go to a fast food restaurant and get food then.
It's not as healthy or something.
That ruins my metaphor, but
Well, the krill doesn't have as much energy. It's not a. They don't. It's not a lot of fat, right? Yeah.
But isn't it's lower down in the chain, so wouldn't it have to eat
More of it.
more of it? Okay, I see what you're saying. each one will have less.
Krill's like the vegetables, and like a penguin is like eating a butter sandwich with butter
So
and
it's like
cheese.
energy
Or something.
So grilled cheese.
Alright, it's like picking berries and trying to catch a rabbit, okay?
Would this be a time for just-in-time instruction if you wanted to go over that really?
Yeah, the calories.
Or like the fact that you spend energy getting food?
Yeah, probably what I'd do in the middle of a unit like this is maybe my next lesson would be, I would use calorimeters and have you guys burn different samples of food. I don't know if you know what a calorimeter is, but
Did it yesterday.
you did. Okay, so what did you burn in the calorimeter?
Cheeto Puffs.
Copies?
No, marshmallows, and then a piece of paper and a candle. We let kids bring in an item they wanted to burn, but most of them, yeah, very few lit. But they were like really determined. Like one group, I sat there for like 2 minutes trying to light their Oreo for them just because they wanted it so badly, and it never happened.
With the discussion now that we have on energy, we might do that calorimeter activity and help kids understand that the krill is, as Taylor said, like a butter sandwich with butter and other stuff on it. It's a penguin, is a butter
Yeah,
sandwich?
the penguin's a grilled cheese, but the krill is
It's
just a
vegetable, it's like a salad.
What's a phytoplankton?
Penguins Oreo.
Water.
You'd have to fix that.
All right.
And I tried this once with our first unit, and I thought afterwards that students could use an example of a kind of what would count as a revision to their model, because some of them, they just didn't know what we were looking for exactly, even though we told them you can add something to your model and be like a new idea we learned from an activity, but that wasn't enough. They wanted, it seemed like they could have used something more specific.
So the first class of the day can actually be a set of examples for your second and third classes of the day for that. Or you can save an image from the previous year. With digital photography now, you should be just snapping pictures of good examples of work that's produced by kids for every unit, because kids need examples. It would have been better if I had had an example up for you guys. In addition to the scaffold instructions, it would have been better if I had an example. Tina, were you going to say something?
Yeah, so you chose to, in our class discussion, highlight the ideas you saw that were unique in different people's things. Is that how you would orchestrate it as a whole class?
Yeah, the reason that I would make my last lap around the room as kids were doing this is to see if a group has a different theory that merits talking about. You have to be careful that they're not completely off base, but there's something there that can be worked on. And that's unique that other groups may not have thought about. And sometimes I name what those theories are, like they have got like an energy part of theirs, an energy theory that's part of their ecosystem theory. This group, if I had to name it, I would say they have like an alternative food source theory going. When one food source goes down, one of those organisms can start relying on another food source, which shifts the balance of stuff. So yeah, I would just pick 2 or 3 and be mindful of where they are in the room and just have those 2 or 3 share out. You have to weigh out the consequences of not having everybody share out.
So what kind of changes have our students made to their models? As their teacher, I see at least 3 major shifts in their thinking and in their language. First, they now recognize the importance of phytoplankton as the base of the food pyramid, and they are starting to understand the relative quantities of food that must be available at each trophic level. This is being expressed more now as a story of energy transfer and transformation. Second, they are beginning to comprehend the central role that abiotic factors play, such as sea ice, and the shifts in climate itself. Third, they are including the idea of competition between 2 organisms that share similar niches in the ecosystem. And fourth, they are hypothesizing about organisms having indirect influences on the survival of the Adelie. The models they have revised and the class conversations have helped make new sets of ideas visible to everyone and available to everyone now as resources to advance our own thinking further.